Lenses. There are two types of lenses. The convex lens. This is convex lens. Convex lens is also called the converging lens or the positive lens. Okay. It's called positive lens is because its power is always positive. Okay, the power is always positive, so therefore it's called a positive lens. And it's converging lens because it converges the lights that pass through it. So it's called a converging lens. And it's convex lens. For convex lens, okay, this is the side. This is the side, this is the side, and this is the center. The centers of the lens is thicker than the sides. Okay, because sometimes some students they see this, they think that this is a concave lens. No, okay. How do we know it's not concave lens? Because the center, the thickness of the center, okay, is bigger than the thickness. Okay, or this is thicker. The thicker in the centers and then thinner at the side. So this is a convex lens. The other types of lens is concave lens. Concave lens, the center is thinner than the side. Okay, so this is thicker, this is thinner here. And then it's also called diverging lens because it diverges the light. Okay, it diverges the lights that pass through it. And it's also called the negative lens because the power is always negative. So two types of lenses, convex, concave, or converging, diverging, or positive lens, negative lens. The important terms, optical center and principal axis. Optical center first. Optical center is a point at the centers of the lens. So this is the centers of the lens. So at this point, there is no refractions which happens when light ray pass through this point. Okay, when there's a light pass through this point, then there's no reflection. Whatever light that pass through this point, there's no reflections. There's no reflections as long as it go through this light. Okay, so then this point is called the optical center. Yeah, optical center. It's also true for concave lens. All the light that pass through these points wouldn't be refracted. So that is optical center. Then what is principal axis? Principal axis is a line. This line, okay, this line that pass through the optical center, and then is at right angle with the lens. Right angle means 90 degree. Yeah? Okay, you can see that this line is 90 degree with the lens, and this line passes through the optical center. So that's the line passes through the optical center and at right angle with the lens. So that is the principal axis. Okay, principal axis. Then how about principal focus and focal length? Let's see this one first. For those light ray that parallel to the principal axis, this is a principal axis. We have a principal axis here. It's not clear here. Let me draw it again. So we have a principal axis here. And these are the light rays that's parallel to the principal axis. This light ray, which is parallel to the principal axis, pass through the lens, it will be converged. For convex lens, it will be converged, and for concave lens, it will be diverged. Okay, no matter it's a converge or diverge, the light ray will be focused at one point. Okay, it will converge at one point. Okay, if it converge, it can converge at one point. If it diverge, then it will diverge from one point. Converge at one point or diverge from one point. So the point where it converge or diverge from is called the principal focus. Now, principal focus is very important. Make sure that you remember this name, principal focus. Okay, so that is principal focus. All light rays parallel to the principal axis. It must be the light ray that parallel to the principal axis. Will converge at the point. So all light ray parallel to the principal axis converge at a point called the principal focus. This is the principal focus, and this point is called the optical center, right? If you still remember, just now we discussed the optical center. Okay, optical center usually is labeled with a symbol O. O. So optical center, principal focus. The distance between this optical center and the principal focus, the distance between these 2 points is called the focal length. The focal length, and then it's denoted by this small letter f. So capital letter F is the principal focus, and the small letter f is the focal length. Okay, focal length is the distance between the principal focus and the optical center. So that is principal focus and focal length. Principal focus, is it the same with focal point? No, it's not the same. Focal point and principal focus is not the same. I will show you when we draw the ray diagram. The focal point can be at any place, but we have only one principal focus. Actually two, each side one principal focus. The focal point and the principal focus is not the same. Object distance and image distance. From the name we know that object distance is the distance of the object from the optical center, and image distance is the distance between the image and the optical center. Okay, I will tell you where the image form later when we learn drawing ray diagram. Object distance is denoted by the symbol U, and image distance is denoted by the symbol V. Yeah? So object distance is distance of object from the optical center. This is optical center, right? Image distance is the distance of image from the optical center. Okay, so these are the important terms that you need to know. Now, it's very important for you to know that because light ray can pass through a lens in either direction. It can from left to right and also right to left, right? So therefore, each lens, it has two principal foci, here or here, okay? This is a principal focus and this is also principal focus, okay? One at each side of the optical center. So every lens has two principal foci. Okay, that are the important terms that you need to know. Okay, power of lenses. Power of lenses is given by this formula, P equal to 1 over F. And F is the focal length, and it's very, very important for you to know that F must be in meter. Meter, T-R-E, okay? So it's a typo here. So focal length must be in meter. So usually in the questions they will give you in cm. They will give you in cm. So change it to meter. Okay. For example, if they tell you that okay, is the focal length is 25 cm. Okay. Then the power P equals to 1 divided by 0.25. Okay. You must change 25 cm to 0.25 meter. Okay. And this is equals to 4. Okay, actually it's a positive 4 because the focal length is positive. Okay, so therefore the power is also positive. If it's the focal length is negative, they will tell you that the focal length is negative 25 cm. So that is how we find the power of a lens. P equal to 1 over F, and the F must be in meter. A lot of students make mistake in the unit. Okay, they use cm, then they will get a wrong power. So that is the formulas of power. The unit of power is called the diopter. Diopter. For example, this one is a positive 4 diopter. Okay, and one diopter is 1 per meter. Okay, 1 over 1 meter. This is called 1 diopter, and it's denoted by the symbol D. Power and thickness. If the thicker lens has higher power and thinner lens has lower power. Okay, thicker lens, higher power, thinner lens, lower power. For convex lens, the power is positive, and for concave lens, the power is negative. So that's why this is also called a positive lens, and this is called a negative lens. Now, in your notes, you have this table. These tables. For converging lens, here you write positive. For diverging lens, you write negative. And thick lens with short focal length, power is higher. Thin lens with long focal length, then the power is lower. So you can see here, this is a thin lens. The focal length is the distance between the optical center, okay, and the principal focus. So this is the focal length. Longer focal length. For this one, it has a shorter focal length. Longer focal length, by using P equals to 1 over F is longer, then the P will be smaller. So longer focal length, thin lens, longer focal length, lower power. Thick lens with shorter focal length, higher power. So that is the power of the lens. Example 1, by using the formula P equal to 1 over F. P equal to 1 over F is in meter. But if you want to use centimeter, then it will be hundreds over F. 100 over F. They give you the power of the lens, and then they want you to find the focal length in cm. P equals to positive 5D. And P equals to 1 over F. So positive 5 equals to 1 over F equals to 1 over positive 5 equals to positive 0.2 meter to positive 20 cm. Okay, so the power is positive and it's a convex lens. It's a convex lens. Do we need to write positive? Okay, for positive lens, you can omit the positive. Just give 20 cm. That's okay already. Yeah? But for concave lens, then you must write negative. Okay, so it means for positive, actually, you don't need to write. Yeah? But for negative, then you must write. Okay, but since it's already given here for positive, so let's put the positive here. Okay, but if you don't write positive, it's okay. Yeah? Okay, so this answer, positive 20 cm. Okay, they give you the power positive 5 diopter, then you can get the focal length is equal to positive 20 cm.